Welcome. In this video I'm going to teach you how to solve an inverse trig function integral. So here we have an integral that says 2x over x squared minus 6x plus 25. Notice two things. We look at this one. We're going to try to do it using completing the square. Method. So we know that the bottom, the denominator can be complete the square like this, minus 6x. So negative 6 over 2, that's 3 squared, that's 9. So plus 9 minus 9 plus 25. That is equal to x squared so let's put this one plus, so that will be x squared plus, that will be x plus 3 squared plus 4 squared. So remember, 6 over 2 squared, that gives you 9 minus 9 plus 25. So let's keep this in mind. Notice if I complete the square, I have to let u equal to x plus 3, but then du is gonna equal to 1 times dx, which is not 2x. That means that I have to do something different for this kind of integral. If I had a 1 here, then I could use this right away, this completing the square, but because I have 2x, I have to do something different. So let's keep this in mind first. Let's put it here. So x plus 3 squared plus 4 squared. We're gonna use it later. So for this type of thing, what we can do is we can add an extra term on the numerator, like as follows: x squared plus 6x plus 25. Notice I'm gonna get the reason is because when I take when I do the u substitution and I take the derivative of du, I'm gonna get the top part. So what I'm gonna do, so what's the derivative of x squared plus 6x plus 25? Is 2x plus 6. That means that I have to add a plus 6 here. So plus 6, but if I add a 6, I have to do a minus 6 dx. What I'm gonna do is I'm gonna split that up. So as follows: 2x plus 6 over x squared plus 6x plus 25 dx minus 6 1 dx. And remember, completing the square, for this one I just write this down: x plus 3 squared plus 4 squared dx. Notice this one, I can let u equal, so I have two integrals to solve to get my answer, my original answer. So for this one, I can let u equals x squared plus 6x plus 25, and then I let du take the derivative, so it will be 2x plus 6 dx, I'm sorry, dx, which is what I have on top. And for this one, let's do another substitution. Let's call it w. So it will be w is going to equal to W is gonna equal to x plus 3, so dW is gonna equal to 1 times dx, and that works out for that one. So let's keep these ones in mind. So okay, so what we're gonna do, this is equal to du over u minus 6 and then 1 over 4 squared plus w squared dw. Notice this technique simplifies our integral, because what's the antiderivative of 1 over u? That's gonna be equal to ln of absolute value of u minus 6, and then this one we're gonna use, since it's an inverse trig, we're gonna use ARCTAN, which is gonna equal to 6 times 1 over A is 2 because A is 4, I'm sorry, so it will be 1 over 4 times arctan of W over 4 plus C. And now let's plug in our substitution variables, and we're going to get the final answer. So final answer is going to be equal to ln, and u, remember u was this one, so it will be x squared plus 6x plus 25 minus 6 over 4, that's going to be 3 over 2 arctan. W is x plus 3, so that will be x plus 3 and then 4 plus C. So this will be our final answer. So when you have this type of integral, you have to do completing the square, and then try to get rid of this by adding an extra term, and then at the end you're gonna get two integrals. One of them is a non-trig, it might be a non-trig or it could be another trig, it depends on the function, but in this case we're working with polynomials, so you're probably gonna get an ln, and then of course you're gonna get one of them is gonna be inverse trig integral. So thank you very much. Please don't forget to subscribe to my video. That's all I wanted to teach you in this video.